Welcome. In today's video I want to introduce recursion and how does it actually work. First I will just quickly explain what is recursion. Recursion is a programming technique where a function calls itself to solve a smaller instance of the same problem. And I want to demonstrate this with a simple recursive function that will add the numbers together. It will be a sum of natural numbers, and I will just simply write it down what I want to achieve. We have the natural numbers sum. And what I want to do is, if I have the sum 4, for example, in that case I want to get a return of 10. And how do we get to the 10? Is simply just adding 4 plus 3 plus 2 plus 1, and we are going to get 10. I will have this solved with a recursive approach. I will write pseudocode, but it will be fairly similar as Python code. Let's just define our function first. So the function, and we will call it sum, and it will have an input of n. And after, we need to get the logic, and we need to think about if this function calls itself all the time, we need to get a base case, and the base case is going to be one that will trigger the recursive functions to unwind after that. What could be the base case in this scenario? Since we're talking about natural numbers, the base case could be when we reach 0. So in that case, when we reach 0, we're going to get to the end of this recursive function, and after we're just simply going to return 0, and this is going to be the base case. Let's just put it into pseudocode, I would say. And to get to the base case, the only thing we need to check if n is going to equal to 0. So if it's 0, we're going to return 0. Otherwise, what we want to do, because just remember that we need to create a function that is going to call itself, that is the recursive part of this function. So in that case, we're going to return the n. It's going to be, for example, 4 plus, we need to figure out what is sum n minus 1. We're going to decrement n to get closer to the base case, and after, when we reach the base case, I will show what happens after that. We have function body, and after, let's just have the example that I mentioned before, and I will use this part. This is going to be our call stack. The call stack will contain every single function calls these bits, so you can visualize how it builds up the stack and after how it's going to unwind. Let's start. First, since it's a stack, it's gonna grow from the bottom to the top. I will start down here. I will have a call of sum4, and let's just walk through. So we have sum4. In that case, n is going to be the number 4. We need to check if 4 equals 0, and this will evaluate to false, so we're not going to get into the if statement. And after it's going to go to the next line, and in that case we can replace n with 4, and after return 4 plus sum 4 minus 1, this will evaluate to 3. In this case we know that n is 4, and this will be waiting because we don't know what does sum n minus 1 is going to evaluate. The next call, sum 3, n is 3, and we go through the same execution. If n equals 0, it evaluates to false, and it's going to return the n plus sum n minus 1. This is waiting, and it will have sum 2. And just to make it visualize it easier, what is actually happening, because we only have system function calls, that this is actually waiting on this function, because this function doesn't know what sum n minus 1 is going to return. And the same thing with this. These are just waiting on the function when it eventually gets to the end, and we will get there in a bit. When it gets to the base case, and after it will be able to determine what is actually sum n minus 1. Write this down. The same thing happens if n is equal to 0. No, because it's 2. And let's just go to the next level. And now we are getting really close. So if n equals to 0, no, we're still gonna have one call. And this is when our execution is going to stop. And let's just walk through the function. In this scenario, n is going to be 0 if n equals 0, and this will be true in this scenario, and after it will return 0. And we know that this will evaluate to 0, and the next thing is going to happen. We will know what is sum n minus 1 evaluates to with sum 1. Let me just expand this, because we knew that 1 plus sum n minus 1, and now we know n minus 1 is 0, and we can cross out that it is not waiting anymore, and we know that this line is going to be 1. And the same thing happens with sum 2, that we knew that 2 plus sum n minus 1, it wanted to know what is that in order to actually finish the function or have a return value. Now we know that is going to be 1. 2 plus 1 is going to evaluate to 3. Let's go to the next line. 3 plus sum minus 1. This is going to evaluate to 3. And 3 plus 3 is 6. And we are at the very last function call, or should I say the very first function call we had, since this is a stack and every single time it's just going to pop off every single system call that it has finished and it has an evaluation. And the last line is going to be 4 plus sum n minus 1. And now we know that n minus 1 is actually 6 in this scenario, and 4 plus 6 is going to equal 10. And if we return the value, since there are no other function calls on the bottom. I hope this video helped you understand more about how recursion works, and for the rest, we'll get to it.